This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. More than 1,000 meters below the North Sea lies what one oil company hopes is an answer to global warming. Since 1996, Statoil, Norway's largest producer of oil and natural gas, has separated carbon dioxide from natural gas during pumping operations on one of its ocean platforms. The company injects the CO2 down into an underground aquifer, where it hopes the gas will remain permanently trapped. It is one of the world's largest attempts to lock away a major contributor to the current dangerous buildup of greenhouse gases in the atmosphere. Researchers at Scripps Institution of Oceanography at UC San Diego began monitoring the sequestration experiment to determine if the CO2 is truly remaining buried at sea.
Carbon sequestration is controversial. I mean, it's controversial from a purely technical standpoint, and that is, once you put the carbon back down into the ground, is it going to stay there? So the point of these various Sleipner experiments is to do reservoir monitoring, to see whether or not the CO2 is trying to escape from the cap rock formation. There are all these good geological and theoretical reasons to believe that it's going to stay there. Natural gas stays in the ground for millions of years. We didn't do anything about it. And you would think that CO2 would also be the same sort of issue. But because we've done something we haven't done in the history of humanity, trying to put that carbon back where it belongs, we need to make diligent efforts in being sure that it does what we hope it will do.
The formation that the CO2 is being pumped into is called the Utsira Formation, and it lies about a kilometer beneath the seafloor, and it's a 200 or 300 meter thick layer of very well sorted sand. So it's very porous. So you have the ocean, and then you have a thick layer of clay and shales, which are kinds of rocks that gas can't penetrate. And then below that you have this very porous sandy layer called the Utsira Formation, and it's that sandy layer that the CO2 is pumped into.
To monitor the CO2 mass, Scripps' research team built the ROV Dog, a remotely operated deep-sea gravity meter. They headed to Norway to deploy their instruments along a stretch of seafloor in order to monitor the changes in gravity above where the gas is trapped, to determine if any is leaking out.
We have a gravity meter, which is a commercially made device designed to work on land. And in a gravity meter is basically a very simple thing. It's a spring with a weight on the end of it. And as gravity increases, then the weight moves down, stretches the spring a little further. Now we've taken that sensor and installed it in a casing that can survive at the bottom of the ocean, and that has motorized gimbals to align it with the vertical, and a computer to monitor all of the operating parameters and send the data to the surface.
As the gas is extracted from the production platform, right, seawater takes its place. Seawater infiltrates through the ocean bottom, takes the place of the gas, comes in from the bottom, fills it up. So now you've introduced high density water. Okay, replace the low density gas with high density water, and there'll be a gravity signal associated with that. Also, there's another signal where the seafloor subsides, is you're basically letting gas out of the balloon.
The researchers are using this information to create a snapshot of the gravity at various points in time. They have been able to detect small changes confirming that gas is trapped inside. How much has leaked out, if any, is not yet known. The research team anticipates the next round of monitoring, in the summer of 2009, will be able to tell researchers conclusively if any of the gas is escaping.
So if you were to measure gravity at the same position as time goes on, what you would notice is that the value of gravity gradually decreases as more and more CO2 is pumped into the formation. So we measure gravity at about 30 stations on the seafloor above this formation, and our goal is for each of those sites to have a graph of the change in gravity as a function of time. Everybody thinks that the CO2 will go down there and stay down there and not leak out, but it's a significant volume of CO2, and we don't want it to, well, if it's leaking out, we want to know about it, so we need to monitor it.
This has been a presentation of Scripps Institution of Oceanography at UC San Diego.